What if the speed of light was not so fast? What if it moved at just 10 miles per hour, about the pace of a bicycle, and how would the universe change? So what is the speed of light really? In physics, c, the speed of light in a vacuum, is not just about light. It's a fundamental constant that ties together space, time, energy, and mass. Einstein's famous equation, E equals mc squared. Energy equals mass multiply speed of light squared. Now imagine replacing c with just 10 miles per hour. That's approximately 4.47 meters per second. Let's recalculate energy for 1 kilogram of mass. E equals 1 kilogram multiply 4.47 meters per second squared equals 1 multiply 19.98, approximately 20 joules. That's less energy than what's stored in a single AA battery. The sun wouldn't shine. Nuclear bombs wouldn't explode. In fact, matter itself would barely contain any usable energy. So now, how our everyday life looks like with the slow light. Let's shrink this cosmic catastrophe into your daily life. If you turned on a flashlight, it would take seconds for the beam to reach the wall just a few meters away. Here's a basic equation for time delay. T equals d divided by v, where d equals distance, v equals velocity. Say you shine a laser at a wall 100 feet away, about 30.5 meters. T equals 30.5 meters divided by 4.47 meters per second, approximately equals 6.8 seconds. That's nearly 7 seconds of darkness before you see the spot appear, and your reflection in a mirror, delayed and ghost-like. Even worse, modern technology fails. Fiber optics, dead. Wi-Fi, gone. Your smartphone's data would take minutes to load even a single web page. Now comes the weirdest part. According to Einstein's special relativity, time dilation occurs as objects approach light speed. The equation for time dilation is t prime equals t divided by the square root of 1 minus v squared divided by c squared. In our world, v is usually tiny compared to c, so we ignore the effects. But if c equals 4.47 meters per second, then suddenly a car going 10 meters per second is exceeding the speed of light. Let's plug that into the equation. T prime equals t divided by the square root of 1 minus 10 squared divided by 4.47 squared, so that is t prime equals t divided by the square root of 1 minus 5.005, and we get the square root of a negative number. You get an imaginary number, meaning under this new constant, everyday motion becomes physically impossible. Time becomes undefined. Cause and effect break. This isn't just strange, it's fatal to the logic of the universe. Now we will see what are the cosmic consequences occur for this. We know that light from the sun takes about 8 minutes to reach Earth. Now let's calculate the new time when the light speed is 10 miles per hour, that is approximately 4.47 meters per second. Sun and Earth distance is 149.6 million kilometers, that is 149.6 multiplied 10 to the power of 9 meters. T equals d divided by v. T equals 149.6 multiplied 10 to the power of 9 divided by 4.47, approximately equals 33.47 billion seconds, approximately equals 1,061 years. That's right, we'd see sunlight that left the sun over 1,000 years ago. Earth would be frozen solid. Photosynthesis? Impossible. Life? Non-existent. And stars? No, we wouldn't see any stars because the light hasn't arrived yet. So what's the big takeaway? Light speed isn't just a speed. It's the backbone of causality, of energy, of time and space themselves. So next time you watch sunlight dance across the floor or glance at a distant star, remember, the speed of light may be fast, but it's also fundamental. If you enjoyed this journey through impossible physics, hit that like button, subscribe, and tell us in the comments, what should we break next?